Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have discussed about bankers algorithms in deadlock and what are the methods of deadlock and what is mean by deadlock characterization. So today in this session, we are going to discuss about memory management. So memory management in operating system. So let us start with our overview of this presentation. So coming to overview of this presentation, in this we are going to discuss about memory management. In this memory management, we are going to discuss about swapping and contiguous memory allocation and what is paging. So let us start our memory management. So what is memory? The term memory can be defined as a collection of data in a specific format. So memory itself says nothing but it is a collection of data. It stores some data in a specific format. That is what about memory. It is used to store instructions and process the data. So in this it stores some instructions and how we are going to process the data. The memory comprises a large array or group of words or bytes, each with its own location. So when we are storing this contiguous memory management, we are having two types. What are they? Fixed partition scheme and variable partition scheme. So let us see our contiguous memory management. In contiguous memory allocation, it is a memory allocation strategy. So in contiguous memory allocation, it is nothing but memory allocation strategy. As the name implies, we utilize this technique to assign contiguous blocks of memory to each task. So we are continuously allocating each memory with the blocks of each task. So this is something task T1, T2 and so on Tn. So we are giving continuously blocks of memory for each task. Thus whenever a process asks to access the main memory, so whenever the process asks to access some main memory, we allocate a contiguous segment from the empty region to the process based on its size. Suppose here something T9 is empty. Here we are allocating some 10.5 MB size of memory for this T9 task. So for this, based on the empty region, we are going to allocate the memory based on its size. That is what contiguous segment from the empty region to process based on its size. In this technique, memory is allocated in a contiguous way to processes. So here memory is continuously allocating in contiguously for each processes, means way to the each processes. And here it is contiguous memory management has been divided into two types. What are they? Fixed partition and variable partitioning. Fixed partition is nothing but static partition and dynamic partition. Static, the name itself stays static, means no changes. The partition is fixed. Whereas variable is nothing but dynamic partition. Here dynamic is nothing but we can change the size of each memory. That is what the difference between fixed and variable. So let us see our fixed partitioning. Nothing but static partition. So fixed partition scheme. In the fixed partition scheme, memory is divided into fixed number of partitions. So here each memory is fixed with some number of partitions, and here the memory is divided into fixed number of partitions. Partitions are nothing but these are nothing but partitions. Each is fixed with some size of the memory. Fixed means number of partitions are fixed in the memory. So here how many partitions are there? 1, 2, 3, 4, 5, 6, 7. So 7 partitions are fixed. For each it is allocated some some memory size with the 50 KB each. So 50 again, for first one is 50, 100, then 250, then 150, then 70, then 220, then 300. So each fixed partition consists of each fixed memory. In the fixed partition, in every partition only one process will be accommodated. So only one process is accommodated. Why? Because it is fixed. Fixed means we cannot change. Only one process can be accommodated. Degree of multiprogramming is restricted by number of partitions in the memory. So here degree of multiprogramming is restricted with number of partitions in each memory. Maximum size of the process is restricted by maximum size of the partition. Here maximum size of the process, here 50 KB is restricted some size of the each partition. So each partition it is having some size for each partition, some size of the memory. For P1, suppose we are taking P1, this partition P1 it consists some fixed size of memory. What is that? 50 KB. So every partition is associated with limited registers. Registers are nothing but storing some data. So in this each consists of some fixed partitions, and for that fixed partition we are fixing some size of memory. And here it is some 20 KB it is allocated. So remaining is in P1 30 is remaining. Why? Because 50. So 20 is internally fragmented. So internally fragmented means internally it is storing some data for this 20 KB of memory. This again how much is left here P1? So 50 minus 20 remaining is 30. So 30 is left in the partition 1. That is how you are going to fix this partition by each memory size. Next, variable partition scheme. In the variable partition scheme, initially memory will be single contiguous free block. So it will be initially allocated with single contiguous by freeing its each block. Whenever the request by the process arrives, accordingly partition will be made in the memory. So after fixing or single we are allocating each block and we are partitioning will be based on that memory. In the smaller process keep on coming, then the larger partitions will be made into smaller partitions. Suppose here it consists of some 300 KB and in this 300 KB that partitions are larger, so that will be divided into 2 or 3 or that will be under smaller partitions. If we are containing larger, that will be made into smaller partitions. In variable partition schema initially, the memory will be full contiguous free block. So here the variable partition schema is initially and the memory will be full of with contiguous free block. So why? Because the variable is initially partition and the memory will be fully contiguous with their free each of the block. Memory divided into partition according to the process size, where process size will vary. So P1 is varying with 50 KB of size of the memory. So each process consists some size of the memory and that partitions are dividing according to the size which are vary. One partition is allocated to each activate partition. So P1 is activating with 50 KB, P2 is activating with 100 KB, P3 250, P4 150, P5 70, P6 220. So 300 is nothing but it is allocated for external fragmentation. So these are the variable partitions, how the partitions have been done with the larger amount of partitions and that are considered into smaller partitions and they are allocated with the each size of the memory. This is what about variable partition scheme. So next let us see about paging. So paging is a memory management scheme that eliminates the need of a contiguous allocation of physical memory. So it eliminates the need of contiguous allocation of physical memory in each paging. The process of retrieving processes in the form of pages from the secondary storage into the main memory is known as paging. So here the process of retrieving processes in the form of pages. Here the processes are converted into the form of pages and that are used from secondary storage into the main memory is known as paging. So each retrieving the process that are formed as pages and that pages are from the secondary storage into the main memory is known as paging. This is what about the definition of paging. The basic purpose of paging is to separate each procedure into pages. So paging is separated into pages. Additionally, frames will be used to split the main memory. So here we'll be having in the paging, we'll be having pages, page numbers and frame numbers also. That frames are considered into are split into the main memory. This scheme permits the physical address space of a process to be non-contiguous. So in this, it permits the physical space, the space between the pages and page numbers or frame numbers that are physical address space of each process, and that should be under non-contiguous. In paging, the physical memory is divided into fixed size blocks called page frames. What I have said, we will be having pages, page numbers and page frames. So in this, the physical memory which is divided into fixed sized blocks are known as page frames. So dividing the fixed size blocks are known as page frames, which are the same size as the pages used by the process. So it should have same size and the page used by the each process. The process's logical address space is divided into fixed size blocks called pages. So the process with the logical address. For physical memory which is divided into fixed size blocks, we are saying as page frames. Whereas in this, we are saying the processes with logical address space is divided into fixed size blocks called pages, which are the same size as the page frame. So whatever the size of the page frame it is having, the pages also should have the same fixed size of each frame. When a process requires memory, the operating system allocates one or more page frames. So in this, whenever it is requesting the memory or a process is requesting a memory, the operating system allocates one or more page frames to the process and maps the process's logical pages to the physical page frames. So in this, a process requests for the memory, the operating system allocates one or more page frames to the process, and that maps with the logical pages to physical pages frames. So logical to physical frames, it will be mapping. The mapping between the logical pages and physical page frames is maintained by the page table. Who is going to maintain this? Page table is going to maintain this, and the mapping will be done between the logical pages and physical page frames. These are maintained with the page table, which is used by memory management unit to translate logical addresses into physical address. So here the memory management unit will be translating the logical addresses into physical address. The page table maps each logical page number to a physical page frame number. Here the page table maps with logical page number and to the physical page frame number. This is what about paging, how we are going to map with the page table, page frames and pages. This is how we are going to map with the map in the paging by using these pages, frames and page numbers. So in this session we have discussed about memory management, and we have discussed about swapping and memory management techniques. Memory management techniques are nothing but two types. What are they? Contiguous memory memory management contiguous memory management. In this we are seeing about fixed partition and variable partition. And next we have discussed about paging. In paging we have seen about page numbers, page frames and how we are going to map with the logical address to physical address by these page numbers. So if you have any doubts, you can comment in comment box. Thank you.